So Anand needs to hire a plumber. He's considering a plumber that charges an initial fee of $65 along with an hourly rate of $28. The plumber only charges for a whole number of hours. Anand would like to spend no more than $250, and he wonders how many hours of work he can afford. So H represents the whole number of hours that the plumber works. So this one, like the previous ones, we're going to have a cost, and that has to be less than a certain amount of money. So the total cost to have the plumber work has to be less than or equal to $250, since he doesn't want to spend any more than $250. So now let's figure out what makes up that cost. And so we know we have a fixed fee of $65, but then we have an hourly rate. So each hour he gets paid $28. And H represents the number of hours that he's going to work. And again, he only works a whole number of amounts, so he's not going to work fractions of an hour. So we'll do 28 times H to figure out how much he actually makes per hour. Since if you put in H is 2 for 2 hours, you would just multiply 2 times 28. So it does make sense that you multiply these together. Now, just putting it all together, you get 65 plus 28 times H is less than or equal to 250. And so that would be this inequality right here. Now, you could go through your process of elimination. It can't be these because that's spending more than he has. And this one, they put the 65, the initial fee, attached to the number of hours, which that doesn't make sense because we have an hourly rate of $28 per hour, and so you would multiply that by the number of hours to find the total amount. So that one doesn't work either. So what is the largest whole number of hours that Anand can afford? So now we're just going to solve the inequality. So minus 65 on each side so that we can isolate the H term. So you get 28H less than or equal to, so if we take away 50, that brings us to 200, and 15 more would bring us to 185. Now we divide. So divide each side by 28, you get 185 over 28, and this is about 6.607. And I'm rounding it here, so the fraction or the decimal actually just keeps going for a while. So this is roughly what H has to be less than or equal to. And we know that the plumber only works in whole number of hours. So he can only work 1, 2, 3, 4, 5, 6, 7, 8, so on. So he's not going to work 6.607 hours. So he's either going to work 6 hours or 7 hours. And since H has to be less than this number, if he worked 7 hours, that would put him past the $250. So he can't afford that. But if he works 6 hours, that's the most that he can afford. That's the smallest whole number less than what we have H being less than or equal to. So 6 hours is the largest that he can afford. And you can test it. You can always check these at the end. Do your 28 times 6, figure out how much that hourly wage ended up working out to be. So 6 times 20 is 120, and 6 times 8 is 48. So when you add these, you get 168. And then we have to add to that our initial fee of the $65. So that brings a 3 there, put the 1 up there. You get 13, put a 1 up there. So 233, which is less than 250, so that works. But if we add another $28 to this for another hour of work, that would put us above $250, since we only have another $17 left to spend in our budget. So we checked it, and 6 hours of work did make sense. Let's do one final question. So Joe is responsible for reserving hotel rooms for a company trip. His company changes plans and increases how many people are going on the trips. They need at least 50 hotel rooms, or 50 total rooms. Joe had already reserved and paid for 16 rooms, so he needs to reserve additional rooms. He can only reserve rooms in blocks, and each block contains 8 rooms and costs $900. So let B represent the number of additional blocks that Joe reserves. So just looking at this problem, he needs at least 50 rooms, but he's already paid for 16. So if we subtract that 50 that we have and take away 16 that we've already our 50 that we need and we take away the 16 that we've already reserved, that Joe has, what we get is 34 rooms that need to be booked. So we can say that the rooms has to be bigger than or equal to 50. And like I said, we've already got our 34 rooms. Now, this part of the problem you didn't need to do, but sometimes just kind of thinking it through gives you a better feeling for the problem. So sometimes you'll do calculations that won't actually help you get the answer, because notice 34 is not in any of these, but at least gives you a different framework for thinking about it. So we know our rooms has to be bigger than or equal to 50. It has to be at least 50 rooms. And so we know we have the 16 that we start with, and then we're going to be buying blocks of 8 rooms at a time. So each block is represented by the letter B. So if we buy 1 block, we'll be adding 8, or 8 times 1. If we add 2 blocks, then we're adding 8 times 2. So we have to add 8 times B, the number of blocks. So that way if we put in 4 here, 8 times 4 is 24. So our 8 times 4 is 32, so that would give us the number of rooms from those 4 blocks. And we know this has to be bigger than or equal to 50. So this is our inequality. And just looking at the answer choices, this one's kind of the opposite of the ones we did before, where we can eliminate the ones less than or equal to 50 because we need at least 50 rooms. If it said we need at most 50 rooms, then it would be the opposite. These B and D would be canceled out. Now, B is the correct choice. It looks just like the one we came up with. This one doesn't make sense because let's say you added 5 blocks, you would get 16 plus 5 is 21, but that wouldn't represent the number of rooms you'd actually have because each block is 8 rooms. So if you added 5 blocks, that would be adding 40 rooms. So you want to make sure that your calculation actually comes out correctly. Now, what is the least amount of additional money Joe can spend to get the rooms they need? Since we know that each block is $900, we can just solve for B here to try and figure this out. So let's subtract 16 on each side. We get that 8B is less than or greater than or equal to 34. So you do actually end up with this number at some point. And dividing by 8 on each side, you get that B is greater than or equal to. So 8 goes into 34 4 whole times, and there's 2 left over. So it'd be 2/8 or 1/4 or 4.25 if we simplify it. So B has to be bigger than or equal to 4.25. And you have to buy whole number blocks. You can't buy a fraction of a block. So we could either buy 4 blocks or we can buy 5 blocks. And if we buy 4 blocks, that wouldn't work. Because think about it. You'd have 16 plus 8 times 4, which is 32. 16 plus 32 is less than 50, right? Because that's just 48. So 4 blocks do not work. So that means we have to go 1 up. So B would have to be 5. And we can check this since 16 plus 8 times 5 would be bigger than or equal to 50. And you get 16 plus 40, which is 56. So our answer worked when we checked it, and we know that the value less than this, 4, when we checked that, we got less than the amount of rooms than we needed. So we can feel confident that the number of blocks we need is 5. And we know that each block is $900 per block. So we just multiply 5 times 900. You're going to have to spend an extra $4,500 to get the rooms that they need. And that's the least amount. They might end up actually spending more.